Hello everybody, my name is Chris Brady, author of the Boeing 737 Tech Guide and the Boeing 737 Tech Site, and today's presentation is about fire protection. So the areas we're going to look at are engine, APU, wheel well, wing body overheat, the cargo compartment, lavatory, and then I'll finish off with an electrical power summary. As always, please treat your company training and their manuals as the authoritative source of information. So, starting with engine detection and extinguishing. This photo on the right, this shows part of the engine fire detector loops. We as pilots probably only think of there being loop A and loop B. In actual fact, each engine's got 4 pairs of fire detector loops. One pair I've shown in this photograph here. It's difficult to see the actual loops themselves, so what I've done is I've highlighted every other segment in red just to give you an indication of where they are. So on the photograph you can see say the 2 pairs of well, firewire it's known as, although I'll come on to discuss what it's made of in a moment. And at the top you can see a pressure switch there. The pressure switch for loop B is round the other end of the loop, and that's how all 4 pairs work. So these loops, they're actually they're in this particular case on the engine APU, they're not wire, they're actually gas charged sense tubes. So they operate the pressure switches, which you can see at either end of the loop, as the gas expands due to an overheat or a fire condition. On each series of 737, each generation of 737, sorry, they've been located in different places as the engines have changed. But on the NG, which is the one I'm going to focus on here, they're located, well, there are 2 pairs each on the upper and lower fan case sections, and they trigger an overheat at 174 centigrade and a fire condition at 304 centigrade. And there are 2 each on the left and right core sections, which overheat at 343 and fire at 454 centigrade. And the pair that I'm showing in the photograph here are on the left core. The APU has also got 3 loops for the upper, lower and tailpipe areas. So I say all 4 pairs of the engine fire detector loops and 3 APU loops are simplified for us in the flight deck as simply engine loop A and B and a single APU loop. Those loops, or rather the signals from the pressure switches at the ends of the loops, all feed into this fire and overheat detection unit, which is in the E&E bay. And the signal outputs will either be normal, which is what we like, or overheat, or fire, or fault. That unit, this fire and overheat detection unit, processes all of those signals and triggers the appropriate bells and lights in the flight deck as necessary. As is standard with all of these boxes in the E&E bay, it's got byte check functionality, and that can give you, with a greater degree of accuracy, it can tell you which particular part of which loop has failed. So rather than just us in the flight decks being able to detect whether there's a fault on loop A or B, this can actually tell you whether it's the core left, the fan lower, the APU tailpipe as opposed to upper. So much more useful for the engineers and their troubleshooting. On the flight deck, as I've said, we can check the engine loops by selecting A or B on the overheat detector switches. If the overheat detector switch is in normal and the fault light illuminates, then that means both loops have failed, as is shown in the photograph here. Failure of the APU loop as in any one of the three loops that we now know they are, upper, lower or tailpipe, will illuminate the APU detect in-op light on test, as also shown on the photograph. The fire extinguishers have got squibs on them. These break the seal on the fire bottle, causing the halon extinguishing to release. For the engine bottles, there are 2 squibs on each bottle. That's because each bottle can be sent to either engine 1 or engine 2. The APU bottle, because it's only going, can only be used in one place, it's only got 1 squib. All 5 of those squibs can be tested using the extinguisher test 1, 2 switch positions shown in the photograph. The panels have largely remained the same from the originals right through to the Max, but there are some subtle differences which I'll just point out here. Pre-1995, so around about when I started flying the 737, which is how I came to take this photograph, the wheel well lights and the fire switches would illuminate on a light test. You can see each fire switch and wheel well light, are on there, and my finger isn't on the overheat test position. That was changed, say round about the mid-late 90s, so that those 4 lights didn't illuminate for a light test, but of course they will illuminate for an overheat fire test. But other than that, the panel's been fairly similar. This is a panel from one of the originals, and it's got a number of differences because this is actually a cargo version of a 737-200. So the cargo differences are that you've got a main deck forward nav cargo smoke detector there up at the top left of the panel, and they're tested with the overheat fire test switch. You can see it's actually annotated smoke A and B at the bottom. The non-cargo originals have got these differences. The overheat detect is simply norm or fire, just 2 position. So there's no A or B testing with the originals, and therefore there's no fault light. That's missing from that stack of 4 lights just to the left of the APU. The other one missing from that stack of 4 is the wheel well light, because that's moved up there to sort of just behind the APU fire switch. Anyway, that's all sort of history and background. Back in modern times, since 2015, the NG and of course the Maxes after them, they've been fitted with this new 2-position locking start lever, which is combined with a fire indication light, which illuminates with the associated engine fire. So again, this photograph's taken on test. The fire switches are normally locked down, but they will unlock it in the following situations. Either an overheat is detected, a fire is detected, or you're doing an overheat fire test, or you press the manual override buttons, which are located just under each switch. The only operational use I can think of that for doing that will be an evacuation. But anyway, there they are. And the overheat fire. 1, 2, 3. Bell cut out 1. Try it again. Bell cut out 2. And bell cut out 3. When the lights are illuminated like that, you should be able to lift up the switch, because they're unlocked. I'm not going to rotate it because I don't want to fire the bottle, but if you notice when they're extinguished and there's no fire, you can't lift up the switch because it's locked. There is also an override lock if you don't want to try the bell test, so you press that down and then you can lift up the switch. These are locked. Can be overridden Fire switches, once pulled, will do the following. They will arm one squib on each engine bottle, and only one squib because it's the squib on the associated side for the engine you're pulling. Remember, there are two squibs, one for the left engine and one for the right engine. They'll close the engine fuel shut-off valve and the spark shut-off valve on the NGs and the Max. They close the engine APU bleed air valves, and for the APU it'll also close the air inlet door. It'll disable the associated thrust reverser, obviously not with the APU, and trip the associated generator control relay. So in other words, it'll disable the Jenny on the associated engine or APU. And it'll close the hydraulic supply to the engine driven pump and disarm the low pressure light, so it's not on as a nuisance for us. And finally, it will allow the fire switch to be rotated for discharge. The fire extinguishant, it's Halon 1301. The bottles are up there in the top right hand corner of the wheel well, and the bottles not only have halon, but they've also got nitrogen, which is the propellant. So they're charged with nitrogen to about 800 psi, and that's the figure that you see on the pressure gauge on the bottles there. Halon is of course a CFC, and due to concern about the ozone depleting properties of using halon, Boeing are this year testing in the latest eco demonstrator, which is a Max 9 flying for Alaskan. They're testing actually about 20 new technologies, but one of them is a new fire extinguishing agent which is made by Meggitt Aerospace. I don't know what it is. I'm sure it's all proprietary and top secret at the moment until they've perfected it. But whatever it is, it's an ozone-friendly fire extinguishing agent. Okay, on to the APU. There is only one APU fire bottle. And I make this point because the APU fire handle can be turned in either direction, which kind of implies there might be two. But it's wired up, so it doesn't matter which way you turn it, you fire the only bottle. The APU fire bottle is pretty similar. I think it's actually either identical or interchangeable with the engine bottles, but it's located right at the back near the APU compartment, so we don't normally see it. Again, when the fire handle is turned, the squib is fired. That breaks the diaphragm of the bottle. The pressure of the nitrogen forces the freon on older bottles, halon on newer bottles, into the APU compartment, which suffocates the fire. On classics and originals, when you're doing your walk around, you could see this. On certain classics, there was a sight glass up at the top there, which showed the bottle pressure. On all of the classics and originals, there were two indicators: a yellow disc to show if the squib had been fired, and the red disc to show if the bottle had either over-temperatured or over-pressured. As I say, these aren't fitted to the NGs and the Max. Now, the only time in my career I've ever had to fire an APU fire bottle in anger was actually on the ground. When I subsequently got out of the aircraft and I went round the back, camera in hand, ready to photograph the missing disc, this is what I saw. The disc was actually still there. You can see it's kind of butterflied open a little bit. You can just see that in the shadow, but from the distance you are away from this on the ground, it will be easily missed. To be honest, I don't think there's really that much point of these. I can't imagine anybody firing an APU fire extinguisher and not putting it in the tech log or not bringing it to an engineer's attention, which is possibly why these discs have been binned with the NG and the Max. But anyway, there they are for those of you still flying the classics. That's where they are and what they do. In the main wheel well, there's a fire control unit for the APU. If you pull that red T-shaped handle down, that will shut down the APU. There's a wire-locked switch just up and to the left. If you move that, that will actually discharge the fire bottle as well. And there's a horn cutout button just on the right-hand side. There is a customer option for an automatic APU fire extinguisher discharge. And on those, the APU fire extinguisher will discharge automatically 10 seconds after an APU fire warning is detected on the ground when the main engines are not operating. In other words, when the pilots aren't present. I haven't flown one of those aircraft, I must admit, so I haven't seen the full spec on it, but my guess, and it is only a guess and I could be wrong, is that the 10-second pause is perhaps to allow you to do the APU fire test. I don't know, I'm not sure. Alright, onto the wheel well. So the wheel well fire detection system uses a similar firewire to that used in the engines and the APU. It's similar, but it's actually different. I'll come on to mention why in a moment. This photograph here I took in the wheel well of a Max, and you can see that there are two loops of firewire there. On all previous generations, original classics and NG, there's only a single loop, so that's an improvement for the Max there. As I've written, almost ironically, there are two large fire bottles located in the wheel well, but again, let me just spell it out for anybody new to type. Although there are two huge fire bottles in the wheel well, they don't serve the wheel well, they serve the engines. There is no extinguishing system for a wheel well fire. If the detection system just lets you know that there is heat of fire proportions in the wheel well, the actions, obviously follow the QRH, but it'll tell you to reduce the speed back to 270 knots to .82, extend the gear, which will hopefully remove and hopefully extinguish the fire source, and then get yourself down as soon as possible. So this is a close-up of the wheel well firewire, and this is on an earlier generation. I can't remember whether this is I took this photo on a classic or an NG, but it's not a Max, because otherwise there'd be two wires. So this is slightly different makeup of firewire to that used in the engines in the APU, which were the gas tubes. This is actually a thermistor element. So what you've got there is a single nickel wire embedded in an insulation, which is impregnated with a salt compound and then shielded in a tube made of Ilconel, which is a high strength nickel alloy. When the temperature of the element rises above 205 centigrade, the resistance of it drops sharply, and that allows a current to pass, which triggers the wheel well fire alarm. You can see this when you do your walk around. It's kind of a large bracket shaped arrangement, but hopefully now you've seen this photograph, you'll be able to identify it next time you're doing your external checks. Alright, on to wing body overheat. So what wing body overheat is telling us is that there's a leak of hot bleed air in the corresponding bleed air duct, and it's particularly serious if the leak is shown on the left-hand side, because that's got all the ducting to the APU. It's a much longer run of ducting, so it could potentially be doing a bit more damage. The system's got sensing elements like the firewire that you saw in the previous slide that runs along the length of the pneumatic ducts. Single loop system, so there's only one length of wire, and this can be tested by pressing the wing body overheat test light for a minimum of 5 seconds. It'll do a check of the continuity of the elements, and both wing body overheat lights should illuminate. And you don't have to do this as aircrew. It should be part of the engineer's daily inspection, but there's no harm if you do it on the ground. Just next time you're in, press this, and you should see those two lights illuminate. So wing body overheat. And as promised, a photo of the firewire for the wing body overheat. This particular area, because it's quite difficult to make out where this is from the photograph. This is showing the sensing element going along the leading edge behind the Kruger flaps, and that large brown duct above the wire. That's the pneumatic duct, which is carrying both the engine bleed air and the air for wing anti-ice. The wheel well fire and the wing body overheat detection share the same detector unit in the E&E base. This is a separate one to the engines and APU, and this is used by engineers to pinpoint in location of an overheat or a fault more precisely than the flight deck panel. Because obviously in the flight deck, it only shows either left side or right side. So this can actually, if you zoom in and read the back of the box there, it'll tell you all the areas that it can detect. But again, it's just background information for us as pilots. I'm not an engineer. You're probably not engineers either. But I find it useful and interesting to just know the sort of behind the scenes on the aircraft. Okay, onto the cargo compartment systems now. In the holds, I've just written many smoke detectors because it does actually vary. There's usually about half a dozen in each hold, but it depends whether your long body or short body aircraft. Now these use photoelectric cells to detect smoke. The smoke detector will trigger for smoke particles, or if the air temperature exceeds 110 centigrade. When that happens, you will see it in the flight deck on this panel here. So each detector is dual loop, and it's powered by DC buses 1 and 2. If one loop loses power or fails, the detector light will illuminate, and the system automatically reverts to single loop detection. In normal situations, when both loops are functioning, and this is the same for engines and APU as well, which are the other dual loop systems, and the Max wheel well, actually now I remember, both loops must detect smoke or heat to give a warning, unless one loop has failed. You can select a single loop on the panel if desired, but that's normally only done to dispatch in accordance with the MEL if one loop's in op. The fire bottles for the cargo compartment are located in the air conditioning distribution bay, between the back of the forward hold and the wheel well. And those of you that have watched my air conditioning, pneumatics and pressurization presentations will remember this photograph. It's a slightly different one to the one I used in those presentations, because this one actually has a cargo fire bottle, and it's highlighted there in the circle. And some aircraft I've got a second bottle which is located on the other side of the mixed manifold. So I say there are options for single or dual cargo bottles, but the panels in the flight deck and the way we use them are identical. The only operational difference for us is that they give either 75 or 195 minutes of fire suppression time, depending whether you're single or dual bottle. The second bottle, if fitted, will fire automatically 60 minutes after the first bottle, unless you've already landed, in which case it won't. So we'll take this opportunity to have a closer look at the fire bottles. Now, I've done this with the cargo compartment because, frankly, the bottles in the wheel well are just too cluttered with other pipework and bits and pieces to get a good look at them. And the APU bottle is inaccessible, so this is the best photograph to show you. But all of the components on here are very, very similar, if not identical, to the other bottles. So up at the top left, you've got the pressure switch there, and that is what sends the signal for the discharge light for us in the flight deck. There's a safety relief valve, and also the servicing, the fill port there up on the top right. Down at the bottom, you've got two discharge ports, and you've got two because this bottle will service either the forward or the aft hole, depending where you in the flight deck tell it to fire to. And this is exactly the same situation with the engine fire bottles as well. Remember, either bottle can fire to either engine, and that's so what we're seeing here is exactly the same process for the cargo fire bottles. Just below the discharge port, you can just see the squibs there. Okay, so moving on, when the bottle pressure is less than 250 psi, so I think these are normally charged to about 800 psi from memory. The pressure switch will then send a signal to illuminate the amber discharge light to tell you that the bottle's been discharged. The squibs on the fire bottle, they're connected to the extinguish lights on the cargo fire control panel. So that's the wiring for those. Just again to put a bit of context on it for us as the pilot, if you like, the end user of this system. It's nice to I always feel to know where these sensors are actually connected up to, what exactly it is we're seeing. So just having a look at some third-party cargo compartment systems. The panel I've shown you on the previous slides is the standard Boeing from the factory panel, but aircraft, particularly older aircraft, particularly these days, often get converted into freighters at the end of their passenger lives, and that conversion is usually done by one of the many third-party organisations that do these retrofits rather than Boeing themselves, and they fit their own panels, and they've got their own supplemental type certificates to do this, and these aren't usually documented in the FCOMs unless the operator puts it in. But anyway, just to show you, some examples of what they're like. If you're flying a mixed fleet of, perhaps cargo aircraft, you might see some of these. I won't go through all the functionality. Those of you flying them, you'll have the information in your FCOMs. This, though, I will just mention, and this is the standard Boeing installed system for Boeing converter freighters. So you've got the normal forward and aft cargo holes, but you've also got a main deck detector and extinguisher there as well. So obviously the layout's slightly different to accommodate the the third column, if you like. Again, going back to third-party main deck protection. So the previous slide showed you the standard Boeing. This is this is one of the third party. This was on a 300 I flew, which had a side cargo door. So there's a heat pad selector just to warm it up, keep it warm, so it doesn't distort, and also smoke detectors for various zones throughout the main cabin. And this again is another option. Again, you've got your smoke detectors up at the top, and the facility to shut off the cabin air if required with the red guarded switch. On regular passenger aircraft, from 2007, the NG cargo compartments were upgraded from Class D to Class C, which is a higher standard of fire protection. One of the changes that Boeing had to incorporate into the aircraft to get Class C certification was that if a cargo fire smoke detector was triggered, the cabin pressure will start to descend at 750 feet per minute. Now, this is about twice the normal rate, and this is done to help prevent smoke penetration into the passenger cabin from the cargo compartments. And obviously, this function is inhibited on the ground because the aircraft's unpressurized. Just a word about the smoke removal configuration. Two of the early steps in the cargo fire QRH procedure, after you've armed and discharged the extinguishers, are to switch the recirc fan or fans, if you're on long body aircraft, off, and both pack switches to high. Now, apart from the obvious benefits of doing those things, because you don't want to be recirculating, smoky air, and you'd like the packs to work nice and hard for you to clear the air through the cabin. There are two background actions which we as pilots are probably not immediately familiar with, and they are that the overboard exhaust valve will be driven open, and the normal and alternate exhaust fans and the equipment cooling exhaust off light fans will be depowered for the remainder of the flight, and they also help prevent smoke from entering the cabin. So I'm sure you would, but my message to you here is please do follow the QRH procedure verbatim, unless you've got an extremely good reason not to, because in missing out one or both of those steps, those two background actions would not happen, because they take their signaling from that you doing those steps. All right, on to the systems in the lavs. All the lavs have got smoke detectors, because there's always some numpty in the back who fancies a cigarette. From 2011, the ionization smoke detectors, which I've shown in the photograph, which, out of interest, contain a very small amount of a mercurium-241 radioactive material. They were replaced with, let's say, non-radioactive dual wavelength photoelectric detectors, similar to the one that I showed you on the earlier photo in the cargo hold. Photoelectric ones, much better, much more sensitive, much more reliable. If the smoke detector is triggered, the amber call light on the locator sign flashes, just to let everybody know that there's a smoker in there, and the cabin crew can step in and do whatever's necessary. And the other benefit with the photoelectric detectors is that they can communicate with the communication system on the aircraft. So you can actually wire these up to. You can have installed in the flight deck a lav smoke detector, if you've got a lav smoke indicator, I should say. Obviously, the detector's in the lav. Well, with the forward lav, you don't need this, because as we all know, you can smell anything that goes on in the forward lav within seconds, unfortunately. But I guess on the aft lav, this has got a purpose. Underneath the lav waste bin, you may see one of these three photographs, depending on what your aircraft is, how your aircraft is fitted. What you've got there is a fully automatic heat-activated fire extinguisher for the waste bin. The top one with the small black extinguisher, that's filled with Freon. The other two are filled with Halon, and the functionality of them all is the same. They're fully automatic. They will put out any fire that is in the waste bin for when, you know, presumably somebody has put a cigarette or tried to, you know, bin a cigarette or whatever it might be. These extinguishers have got two nozzles. They both fire into the waste bin. On the black bottles, which are at the top, the nozzles will change colour from a black to an aluminium colour, and they'll melt after discharge. You know, so these do need replacing after use. Rather than inspect the nozzles to see if anything's happened, what you can do is you can just check these temperature plates on the outside. So again, we get no indication in the flight deck of activation of these extinguishers, whilst on some aircraft we get an indication of smoke. We don't get indication of the extinguisher operating. So on the outside of the waste bin compartment, there's usually this decal, and always these temperature plates, and they simply turn black depending on how hot the temperature's been inside, and that should be part of the cabin crew checks on a turnaround. Alright, last thing I'm just going to finish off with is just a quick summary of the electrical power. There it is. Bit tricky to take in like that, so what I'll do is I'll just display it this way. So again, those of you who've watched my electrical presentations will be familiar with this. So the hot battery bus gives the power for extinguishing for the engines, APU, and cargo fire. So all the important extinguishing things come off the hot battery bus. That is always powered. Always, well, say always, as long as you've got some charge in the battery, you will always have extinguishing capability. Detection of engines, APU, and wheel well fire come off the battery bus, so that is almost always available, should we say. The lav smoke detectors come off DC bus 1, and DC bus 2 give the cargo fire detectors, and the AC transfer bus 2 is actually also a second source for wheel well fire or overheat or fire detection, the other source being the battery bus. And finally, the lav waste extinguisher, that little black or green bottle underneath the sink there, no power required for that. It's fully automatic. It just does its own thing, which is great. So that's it from me. You now know as much as I do about the 737 fire protection systems. As always, if you've enjoyed the video, if you've found it useful, give it a like for me on YouTube, subscribe to my channel, tell your colleagues, and I'll see you next time for the next video in the series. Thank you.